I would like to talk today about zero trust architecture with Keycloak. The reason why I want to talk about this is we've had a couple of use cases where we've actually tried to move from this perimeter-based security into a zero trust approach. And in most of these use cases, so I think Johannes mentioned in the beginning, he's maybe the only project that doesn't use Keycloak right now. But in most of these use cases, we actually have Keycloak as part of our setup, as the main identity provider. And I would like to talk a bit about this because we all know Keycloak is great. We all know that we want to use it. It's the de facto standard when it comes to open source identity solutions. The question for me is more like, what can I do with it? What can I do around it? So what can I build on top or with Keycloak so that it brings value to perhaps a bit more than just identity and identity management and user management. And this is how we came up with this idea of zero trust. So what will I talk about today, or what will you hopefully hear? I will start with a basic look at what is this conventional architecture when it comes to security, so this perimeter-based, network-based security, versus what is a zero trust approach, and why do we actually think it's a good idea to switch from this conventional to the zero trust. Then I'll mention a bit about the difference between user identities and machine identities. So obviously Keycloak focuses strongly on user identities. But when we talk about platforms, when we talk about large projects, then machine identities are also something that plays a part in the setup usually, and we can see how they work together. I will then give two examples. One is a large platform where we need to have this generic solution that works for, in essence, bring your own code. So you provide a platform for developers, they can deploy their applications, and the applications need to be secure, they need to have user management, they need to have machine-to-machine communication, they need to have secret or access to secrets at build time, at runtime, database connections, so on and so on. And then we will take a look at, let's say, perhaps smaller or simpler example, where we will see how we actually set this up on a dedicated application. So maybe lower the scope a bit, lower the generic approach a bit, but on the other hand, then be able to use more features because we don't have to be so independent and so broad. Finally, I will give you my opinion on what makes sense for me and what you guys could use in your projects. But during the whole time, you will see that for a lot of things we've made some trade-offs. Some trade-offs were good, some maybe less good. So if you have questions or if you have opinions that contradict mine, just yell and we'll give you the speaker stick and then we can discuss stuff. So first, who am I? I already mentioned, my name is Damjan. I started my career as a software developer, mostly backend, then moved towards DevOps, cloud engineering, platform engineering, so a lot of stuff. I've worked on a couple of Keycloak projects, so hopefully I have some background experience and knowledge in Keycloak, but as I said, I see myself as a learner, not as a teacher, so not all I say is true or valid, but I believe that in the context it was hopefully the correct decisions. So we start with the very basic, and I'll try to kind of rush through the slides in the beginning so we can talk more about the use cases. But please, if you would like to spend more time on anything, just raise your hand and we can discuss it. So we start with the basics. What is perimeter-based security? In this security concept and how things were set up before, for a long time, we used to have these zones, these perimeters, where we would say, okay, when I set up my infrastructure as a large company, I have let's see if this works, yes. I have my people that live outside, that are in the internet, that I don't trust at all. But these people are what actually makes money for my company, so I need to somehow give them access. So I don't trust them, but I want them to be able to access my services if they pay for it, right? So I have my demilitarized zone, which is a fancy word for the first layer, which people can access from the internet. And there, hopefully, I do some checks, some validations. I have some web applications, some load balancers, doesn't matter. And I have some security control at the perimeter where I say, Yeah, I check every request. Either it needs to come from a verified device, IP, whatever that might be, or we need to then handle authentication authorization. Then we have our second perimeter, which is an internal zone usually, which means, yeah, at this point, traffic cannot come from untrusted sources. Traffic has to come from the DMZ, so a somewhat trusted source. And the thinking goes, well, I've checked access here. This thing handles authorization authentication. I can only reach my internal zone through the IP range of the demilitarized zone, which means, in essence, I can be more or less sure that the traffic that flows through here has been checked and verified. And finally, people have their privileged zone where the database lives, where maybe Keycloak lives, where obviously Excel lives, because no company can survive without Excel. And all of these things kind of add an extra level of security in the thinking, right? So we have this extra firewall that says, yeah, we do some more checks here, and then you can go through only if we trust you, and once you're in, which sounds good on paper, because then we get rid of all the complexity within this zone. So once you're in, you're trusted, we're all friends, you can do whatever you want in. Problem is, once you're in, you're really in. So if you get in through whatever means into a zone, that means that you can do more or less anything there, because all of the controls are at the entry points. All of the controls focus here, and there are no controls at the endpoints or at the services and applications that you're using. This is problematic because, yeah, if you get access through whatever backdoor, leaked password, doesn't matter, then you can do some really serious damage inside. On the other hand, you also have the problem that you need to handle these controls at 3 places in this case. So you need to set up controls here, then here, then here. You need to manage them in a distributed way. And at the same time, very often companies create these VPNs where they virtually extend their network range. So they take this slice here and create a smaller slice here, and they say, yeah, it's not really part of the same slice, but we treat it as if it were. And they justify this, or people justify this with, yeah, I need to get external devices, trusted devices like my employer's computers or so on. I need to give them access to the network. But what in reality happens is that you're building in backdoors and then shipping them off to people. And you kind of lose control of what happens then, right? And if you don't treat this really as a serious thing, as something that actually is an entry point, and then you need to apply the same rules as you do with any entry point into the system, then you can very quickly get into trouble. I've said a lot of bad things about this perimeter-based security, but in reality, this worked or still works for a long time. So this is a tried thing, it's a tested thing. It actually, there is nothing saying you cannot use Keycloak with it, but it kind of is what most of the IT infrastructure used to look like. So why are we saying that this is bad and we want to go to something new? In reality, this is not so bad. It works. I cannot argue that it doesn't work, but there are some problems, and especially problems pop up once you go to this cloud native approach, where IPs are no longer fixed and network perimeter is no longer fixed. And this thing might be in the DMZ now, but might move into the internal or might move back. And things are in constant motion, fluid. Things change very often, so you cannot really define a parameter or a perimeter around the services. You want to have this flexibility. You want to be able to change things and move things around. And this is where the concept of zero trust comes in. I don't know why my pictures are so bad, but you get the idea. So instead of having these parameters, what we say right now is we'll have these mini parameters around every application we have. So every application is considered a perimeter on its own. Every application then needs to have controls, security controls. We push this down basically to every place where something happens in our system. And we always authenticate the requests, and we always make sure that they're authorized. So IDs obviously become much more important, because at every place here, we actually want to, okay, maybe not at Excel, but at every place we actually want to check is this ID valid? So is the identity of the requester valid? Is the person that requested this authorized to do this? And this again has like 2 points. On one hand, are they authorized in the sense, are they allowed to do this at all? On the other hand, is this part of the scope of the request? So is this something that the user intended to do and not that somebody intercepted the credentials and then tried to reuse them for another purpose? And when you do zero trust properly, the idea is that you have these checks at every point. So this is why it's called zero trust. You don't trust any request. You don't trust based on where the request comes from, but you check everything. Check, double check, triple check. And this is a lot of talk about trust and a lot of talk about identity. And now we do a bit of a side note, which is one of my favorite papers. You can see it here. Basically, it means what is actually trust, or what do we trust? I think you'll get the slides at the end so you can download it. So the problem with trust is that you need to have a root of trust. So you need to be able to say, okay, I trust the discussion with the authenticator before, right? I trust my authenticator, whether that's Apple, whether that's, I don't know, Chrome, whatever. I trust that they've done a good job. And on top of that, I build my entire infrastructure. And the idea is, yeah, I have my thing because I trust Apple, who then trusts the hardware manufacturers, who then trust someone else. The point is, you can go very deep with this thing. And this is exactly what the paper is about. So in essence, what it says is, you cannot trust any code that you don't see. But even if you see the code yourself and you write the code yourself, you still cannot trust it because you don't know how it's compiled and you don't know who wrote the compiler that compiled your code, which in essence, it even goes and proves theoretically that you can build a compiler that introduces a Trojan in any code it produces and then removes it from its own source code. So in essence, it's completely untraceable. And then you go down the rabbit hole, then you're like, what can I even trust? And obviously with hardware, it's even more difficult to verify. And yeah, on one hand, if you're dealing with security and you're not a bit paranoid, then are you really dealing with security? On the other hand, it's not paranoid if they're really out to get you, so something to think about. Just a side note. We get then to the next big topic. So the question of what is a user identity versus machine identity. I have here two examples. So one big thing about a user is that the user is a person, right? This is someone who belongs to a group, whether that's the service call agents, whether that's outside users, some admin here, completely outside of everything. But it's a person that I can then talk to potentially. So it's a human being. Why is this important? Because if I track the request that comes to my system, and if it's coming from a person, then I can talk to someone and I can ask, did you do this? Was your credential compromised? Did something happen? Did you intend to do this? Is this part of your job? Are you supposed to do this? Well, when we talk about machine-to-machine communication, then yes, the code is the truth, but in essence, we cannot verify, especially if the code was written by someone that's no longer in the company or whatever, we cannot verify why certain things happen in the way that they do. When it comes to users, we also have the option to actually have this least privilege. So we can say, okay, I now need to, I don't know, write my Excel, so I will just log in as standard Excel user, write my spreadsheets, all good. But if I have to, for example, reset a password in Keycloak, then I need to log in as admin. And I can be the same person. I can log in as two different roles, depending on the privilege I require. And this lowers the risk that my credentials are exposed, lowers the risk that they're compromised, lowers the risk that I do something that maybe I don't want to do. And this is an important concept. Not everyone does it, not everyone uses it properly, but it allows you to have this kind of least privilege baked into the process, and you can decide when you're using or when you're logging in, you can decide what do I want to do, and based on that, only get access to the systems that you're using. With machines, it's more difficult because the machine, yes?
Is there a difference in the authentication there as well, or is this only a drop-down? I need this.
It could be both. So it could be, you could have, so this is a decoded JWT, so JSON Web Token, and in it we see here we have, for example, the roles for the realm, the roles for the resources, and somewhere here, group membership, right? And you can actually have it so that in Keycloak you can configure it so that when you log in, you say, there's this consent screen and you can choose which resources, I think in the OAuth flow they're called. So you can say, I want to basically authorize access to something that I own and I want to only access Excel today and not Word, for example. Stupid example, but you can really pick on a fine-grained level what you want to do, and when you potentially need more privileges, then you potentially have to go through the sign-up process again and then elevate your privileges or elevate the scope. I think there's also the scope here, which currently is email profile, but you can also extend it with like what resources you want to access. This is true for Keycloak, this is true for JWT, this is true also, for example, for cloud providers where you can, they even recommend that you have two separate accounts, one super admin and one normal account, so that you cannot by accident log in with the super admin and destroy everything you've built, for example. So from a perspective of login, it's the same credentials potentially, depending on how you implement it. It's the same login flow, but during the login you can choose which role you want to sign in as. Or you could have, in the case of, for example, AWS has this strict requirement that a super admin needs to be a separate account. And then you as a person have two accounts and you need to choose during login which account you want to use. So it's a matter of implementation. But in any case, I would recommend that always you have this least privilege. So you always try to log in only with the least amount of privileges that you need to get the job done. So especially when you go into this redirect flow, so you go to an application asks you to log in. The application can send to Keycloak the request that says, this is the scope, this is what the user should be able to do. And then the user will get presented with this scope, and then the user can choose, okay, I want to let the application more or less access these resources. And then this gets all encoded here, for example, if you use OAuth and JWTs, and then the downstream services can then verify this scope, and if the scope is not the proper one for the downstream service, if we go back. So for example, if you say, here you do the redirect, you give it scope to access this site with the database, and then someone tries to access this site with Excel, then this service here should be able to say, hey, the token that you send me, even though it's a valid token, is not for me, it's for another service, so I will not give you access. With machines, it's a bit more difficult because the machine, in essence, needs to have this master key, master credential, because it needs to be able to access both roles, right? And of course, we can say, okay, based on the code, we decide and we only request access for the lower privilege when we need it. Problem is, if the machine itself is compromised, then the attacker can use higher privileges. So while your code might work well, as soon as the machine is compromised, credentials are there, and then the attacker might use the higher privileges. One final point here is, this is the decoded JSON Web Token. I don't know how familiar you are with JWTs, but the essence, the thinking behind it is, I pack all the information about the user and about the authorization, groups, roles, scopes, so on, into a JSON like this. I take this JSON, assign it with a key that Keycloak has. So then the application that actually needs to verify this can just go to the issuer, so Keycloak, ask for the public key, use the public key to verify the signature, and in essence the public key can be stored client-side or application-side, which means if I have a billion applications, they don't have to all call Keycloak. They can all verify locally that this is true, it's valid, and I have access to certain things, which sounds good on paper. There are some problems with it. One problem is how do you sign out? So usually with JSON Web Tokens, you cannot really sign out because the application never calls the central server, Keycloak, to verify if you're signed in or not. That means that for the validity of the token, which is set in the expiry field, you cannot be signed out technically. There are some workarounds, which I'll talk about in a second, but in essence, it's very important to set this expiry time to a very low number, because otherwise the token is valid. If it's leaked, if it's stolen, there is no way to invalidate it. One workaround is to basically say I have a blacklist of tokens that have been revoked, which means then the application has to call Keycloak every time and check if this token is on the blacklist, which then means that you negate this advantage of not having to call Keycloak. So then you might as well have just any opaque token that you verify every time. So it's a trade-off. It's a balancing game. We will see that for certain things we use this thing, for others we don't. I would say if you can avoid it, use a normal token. Don't use a JSON Web Token because most of the time you don't need it. So this whole thing of, yeah, I can make a decision locally and I don't need Keycloak to verify the token every time makes sense if you're Google and you're serving billions of requests. If you're serving a reasonable amount of requests, usually Keycloak can take it, so just verify the token, make your life easier. And this is exactly these billions of microservices that I wanted to point out. So usually what you can do and what I would recommend and would try to do is whenever there's an action in the system, whenever you try to do this call between microservices, this is most of the time triggered by a user. So there is a user that says, I want to write something in Excel or I want to write something in the database. And most of the time you can use the identity of this user, propagate it through the system and authorize, authenticate at every point and be successful at the end and actually get the job done. So most of the time you don't need machine identity. It's a nice extra feature, but ideally it shouldn't be necessary because machines don't do things on their own. Usually it's a human telling them what to do in the ideal case. Let's see how it goes with AI. But in any case, this helps us in two ways. One is auditing. So we can track the process. We know who triggered it. We know why it was triggered. On the other hand, it helps us with just not having this extra, is this a person? Is this a human user? Is this a machine user? What is this machine user allowed to do? How do I deal with least privilege when this machine user here has to perhaps have credentials for multiple tenants, which are not allowed to talk to each other? How do I take care of that? We will see later in the talk. But also a very real problem is this billions of microservices. So if you think, or a long call chain, for example. So if you think that the job that we issue here is something very short-lived, and then you need to call a couple of services, and this job is obviously reused, it might happen that here it checks out, here it checks out, here it checks out, here it's already expired, and then your entire call fails. And then you need to go back again, tell the user to re-authenticate or use a refresh token, and then make the call again and make the user very unhappy. So in some cases, people say, okay, we just check at the first point if the user issued the request, and then here, this machine and this machine trust each other, so we use machine identity and so on and so on, and that way we are in no danger of the token expiring, or at least the token expires immediately at the first entry point, which means we don't waste work, because work then needs to be redone, and we let the user know as quickly as possible so the user doesn't wait. Sounds good on paper, but as I said, there are some trade-offs to that as well. So with that, I think we get to the examples, and here I just have the basic graph, and I will try to point out certain things how we did this. So this is a real life example of a project that we've set up. This is this platform where developers can deploy their applications, and by default the application should be secure and they should be integrated with an identity management system, and they should be accessible from like developer team members and also from customers, and a lot of complexity. And yeah, I will try to point out what I believe is important, but again here, so I'll try to kind of play with time. Just interrupt if you want to focus on something in more detail. So what is the basic setup? We have, so this whole thing is deployed in Google Cloud. We have, in essence, you can think of it, so Google has this concept of VPC, Virtual Private Cloud. It's basically this concept of perimeter-based security where you get a network slice that's private for you only. In this VPC, we have deployed a Kubernetes cluster. There's the logo there. And in it, we have different namespaces. Namespaces are given off to teams based on, technically not a team, but a product domain, but let's call it team for now. And then we have a separate VPC with a separate cluster and VMs, so I won't go into details. Technically, it's, I think, 2 clusters and a couple of VMs. But in essence, we have a separate management plane where we have Keycloak, where we have GitLab, where we have HashiCorp Vault. And this is kind of integrated, or you can talk between the 2 VPCs, and also you can talk from the outside. Obviously, we want developers to be able to go to the management plane and log in with Keycloak, for example, or send code to GitLab. We don't necessarily want users to go to this management plane because they have no business there, although technically there is a use case which we kind of implemented with Keycloak where users can also go here. So what is the setup, or how does this work? Well, we have Keycloak as our central identity provider, and it does several things. First, we have identity federation with Active Directory, which means you can use the company single sign-on, the Active Directory account to log into Keycloak. And once you've logged into Keycloak, you can log into all of these services. So then you have access to GitLab, you have access to Vault, you have also access to the cluster management plane, and so on and so on. So as a developer, you can just go to our Keycloak instance, you log in, you have access to all of the services that you need. This is a very simple use case, but it also kind of has a bit of complexity, especially because of this Active Directory integration, which then needs to be synced. And then we have an extra layer here, which is an old system used at the customer, ZBS, Zentralberechtigungssystem, whatever, which is an Oracle database with permissions, basically. So this is also integrated into Keycloak. So we are able to actually look at the permissions that are in Oracle, look at the group membership and the directories in Active Directory, and come up with some sort of reasonable answer on what is this person allowed to do, what are they supposed to do, and which services can they access. The primary thing then from a developer perspective is GitLab. So they can actually log into GitLab, and once they log into GitLab, they automatically have access to the group of their team. And there they can create resources, they can create repositories, or repositories are created for them, and they can basically start working, committing, whatever. So we base the GitLab identity then based on Active Directory, and here you have certain permissions. So you can either commit code, or you can run pipelines, or you can deploy stuff based on who you are coming from Keycloak. GitLab then is able to go to the cluster and actually run GitLab CI jobs there. And here we get to the next interesting point. So at this point, we need somehow GitLab to be able to go to the cluster and to be able to actually submit a job and start working. And here we had a couple of options. So one thing is, obviously, when you start a job in GitLab, you start it as a user. So whether that's through a commit or whether that's through clicking a button, the job belongs or is bound to a user. GitLab also allows you to have scheduled jobs. So we arrive at the first problem, which is a scheduled job does not really belong to a user. So technically a user scheduled it, but that user might be long gone, might be something left over. And at this point, we cannot really rely on the user identity. So here we had to go for the first time into this machine-to-machine thing, where we said, okay, GitLab itself can authenticate against the cluster and can start jobs as GitLab, but GitLab injects with it the user that started the job, if there was a user, which means once this job starts, and let's imagine we have a build job that's supposed to go to a Docker registry, stupid example, not the actual case, but let's go with it. Go to Docker registry, download a base image, build an image on top, and then push it to the registry. And obviously we need to authenticate to the Docker registry. One approach is to just say, okay, in this namespace I put a secret, that secret can go to the registry, it can authenticate, all great. Another smarter approach would be, okay, GitLab injects the ID of the user, it injects a token which I can then use to either go to Vault and fetch a secret for the GitLab registry, or do a cool thing that Google calls workload identity, which is more or less bind the identity of the pod, of the executable, in this case of the application, to a Google identity, and then use that to authenticate against the registry. In any case, here we decided for the machine-to-machine approach for practical reasons. And yeah, you will see that in a couple of other places we also have this kind of fighting between machine-to-machine and user-to-machine, which is something that, which is why I thought it was so important that we get into it in the beginning. Once the build is done, the application is deployed, it runs in the cluster. So at this point we have 2 or 3 use cases. The application, once it's deployed, it automatically gets a sidecar from Istio. Istio is a service mesh, open source. In essence, what it means is it has a, let's call it, little helper there that is supposed to handle all networking for you. What do I mean by all networking? It should do load balancing. It should do rate limiting, for example. It should do service discovery. And most importantly, it's able to do authentication authorization. And it's able to do, or it supports both use cases. It supports machine-to-machine with MTLS, so mutual TLS between the different machines. And it supports Keycloak as an identity provider. And this is exactly what we use it for. So we have our Istio set up in such a way that if we deploy an application, we can with it deploy a authentication and authorization policy, which is just a YAML file that says in Keycloak, these groups have access to REST paths, which means when I come as a team member, let's stick with a team member for now, when I come to test my application because I deploy it and I just want to see it, that it works, or if I come as a business user to actually handle some back office applications that are not exposed to customers, but are used by business users to configure, I don't know, delivery time windows is one example. Then I can log in with Active Directory, which takes me to Keycloak. So then I use Keycloak to log in. In Keycloak, I'm assigned to the correct groups and I have the roles. Let's say I have the role of time window maintainer. And then I can go to the application and the sidecar. So my application doesn't have to know anything about Keycloak, doesn't have to know anything about permissions. Ideally, you should know, but let's stick with the example. Doesn't have to know anything about permissions, doesn't have to know anything about authorization, authentication. This will be enforced by the system that we as a platform provide. So once the request comes in, the sidecar will block the request. It will check if there is a JWT available. It will check if it's expired or not, if it was issued by the correct Keycloak, so that you don't get staging, development Keycloak issuing tokens for staging, for example. And it will check if the groups that, or the roles that you have defined in this policy actually match the path that you're trying to access. So if you say, I want to access / delivery time windows, but your group is not delivery time window maintainer, it's, I don't know, logistics maintainer, then it won't let you through. It will say, hey, the group is wrong. Either escalate, so increase your privileges, or log in, or just go away if you're an attacker. If, however, you have the correct group, then it allows you to pass through. And If it's a simple application, if it's just CRUD, then you can say, okay, I completely offsource my authorization policy to this Istio thing. Platform provides me with a way where I can just have a YAML that say these endpoints go to these groups, other endpoints are available to other groups, and my life is easy. As a developer, I don't have to do anything. We also have the option to pass the token through, and then we say, okay, we do the preliminary check. We at least check that the token is there. We at least check that it belongs to, stupid example, the correct company. After that, the application still needs to handle authorization. That's also fine. That's also an option. The option is then, of course, that the application can forward the token if we want to try to mimic this, the user identity is propagated through the services. We can also have here, and we use this in a special case, an extra component, so this OPA, so Open Policy Agent, where we can say in addition to getting the token from Istio, we actually want to forward this token to a third party, so an external policy engine, which can have much more complex policies, which are then defined as code, and we can say, okay, I have the token, I have the information on the identity, on the group membership, on the roles, and the access that it requires. And I have a policy somewhere that can tell me if this user is allowed to do that or not. This we tried in a couple of special cases, but we don't really use because just the overhead of having this external policy usually is not worth it, because on one hand, we as a platform cannot provide a generic policy that fits everyone. On the other hand, offering this to the developers is just too overwhelming. So they already need to define an Istio authorization policy. Then if you tell them you need Rego with an OPA policy, then it just gets too much. So the compromise that we decided on is you cannot go to production without having an authorization policy for Istio, which basically needs to say which Keycloak you accept and needs to say at least which endpoints you have and which group has access to them. With that, you can go to production, and with that, we are at least sure that the basic minimum of authorization is there. What you do then within the application, or if you want to extend this policy, then this is left up to you. What we were also able to do with Istio, which was also a very cool, although somewhat complex thing, and Tamas knows most about it, there's this OAuth2 proxy, which allows us to basically embed a rule here that says, so right now the way it works is I go with the JWT gets verified, calls Keycloak, gets the public key, checks the signature of the JWT, makes sure everything is fine. Problem is, if I don't have a JWT or a token and I go straight here, so as a user, for example, for the first time and try to open a web application, this thing will tell me, well, you have no JWT, sorry, cannot help you. So it won't even let me load anything because I'm not authenticated, right? Zero trust means you get nothing. So we have two options. One is to say to the developers, hey, you need to have a /public endpoint where everyone can access it and where you serve at least a redirect to the authentication, which means we need to teach developers about redirects and about Keycloak and about how to handle an OAuth2 flow and so on. Or the other option is we just have here a rule that says if someone comes in without a token, you can automatically redirect them to Keycloak. And this actually worked rather well. So we were able to set it up so that if you come in and you have a token, then we check the token, let you through. If you come in without a token, then we can immediately redirect you to Keycloak, ask you to authenticate. Once you do that, we get the token back, we check the token, all works out. It's a bit messy because when we were deploying it, Istio did not support this out of the box, so we had to go kind of deep to the envoy filter, so the component that Istio uses underneath it, to actually get it to work with the redirect properly. But it works. If you're willing to invest, I don't know, a couple of weeks of your life, then you can get it to work. Otherwise, at some point we said this is not worth it because we also have to support it. We also have to keep up to date. Istio releases new versions often. The filtering mechanisms, endpoints change very often, so we kind of ditched it as far as I remember, Tamas, yeah. And we said, okay, we will have for most services a public endpoint where you can expose things to the public, and then you have to redirect them. And in any case, we said most of these things should be only available to developers and team members and not really end customers. However, there was one special use case where we did develop something for end customers. And in this case, we really had, like, with the ZBS, it was user federation. We said, okay, we have the users, we have the rules in the Oracle database, you can just go to it and you can get them, and you have user federation, and Keycloak is the source of truth. For customer data, we actually were not allowed to store anything in Keycloak, because back then, and this is like a couple of years ago, early on, we were still fresh in the cloud, and the company policy was no customer data in the cloud, at least in the beginning. Now things are a bit different. But what we did is basically we had to develop a plugin for Keycloak, which allowed us to do a more or less pass-through. So we go to Keycloak, so to all of these systems, it looks like the exact same normal flow that we know. But Keycloak actually then goes to an external system, which is the on-prem repoint, whatever authentication system. And there they check the customer password and username, and then they actually give Keycloak an indication of whether that was okay or not, along with some extra information that we might need here. And at this point, Keycloak does not store the customer username, does not store the customer password. It just lets it kind of pass through. So this was also a cool kind of window into the extensibility of Keycloak and why Keycloak is such a good solution, that it allows you to actually go in, write, I don't know, 1 or 2 Java classes that you can plug in, and then you have something that meets your requirements even for sensitive customer data. Vault is maybe the final thing before I have to go to the next slide, because we're running out of time. So with Vault, we had similar problems. So on one hand, we want this application to be able to go to Vault, get a password for a database, and then reach a database. On the other hand, we want the developer to be able to reach the same database, which means the developer needs to go to Vault and get credentials for the database as well. So what we were able to do is plug Vault into Keycloak and tell Vault, if a developer comes in, wants to log in, you have to ask them, in this case, exactly for the role. So what are they trying to log in as, based on levels, privileges, whatever. And if the developer asks for the role to access the database, and if they have this role, then basically give them credentials to access the database. It's actually very cool what Vault can do. It can generate a dynamic username and password for the database, which is valid for the duration of what they call the lease. So basically they give you something that expires soon, and then you can use it, and then after you use it, it's basically gone. So both the username and the password get deleted, and then it cannot be compromised ideally. And you can ping Vault to extend the lifetime if you need it for a longer time, but generally you can set it up to expire in 5 minutes, and then you should be most of the time good to go. We were able to do the same thing with applications, but this time using this machine-to-machine identity. So an application can then go to Vault and say, I am the delivery time window service, and I need access to the delivery time window database. It will present its credentials based on workload identity. So actually the machine is able to cryptographically prove its identity, prove that this is the code that should have access. If you're curious how, we can talk about it later. I'm running out of time. But in essence, it can prove that it is really the application that has access to this database, and based on that, Vault will give it, again, automatically generated credentials, and you can use then these credentials to access the database. What is the drawback here? The drawback here is then, as I said, if somebody compromises this application, they can freely go to Vault, they can ask for the credentials, and then they have full access to the database, which is fine. Fine. Is as bad as compromising the credentials directly if you have just one tenant. The problem comes if you have multiple tenants, then compromising this machine compromises all of the tenants. Compromising just one service member or service user compromises only that specific tenant. In this case, we had to go for this trade-off because, we were not able to propagate the JWT, and also because of architectural decisions made on the customer side. But this is a real problem that we saw and that we learned from, and this is a bigger picture, too late, and that we try to then improve in our application setup. So this is the second thing that I mentioned. And in this case, we again have different tenants, also on the database side. We have our user who is supposed to go to the front end and upload some payment data. And obviously, once they reach the front end, they'll get redirected to Keycloak, where in Keycloak we have different realms for the different tenants, and they can, based on who they are or which realm they go to, they will get a token for their own tenant. And at this point, it gets interesting because then the front end will send this token to our application. And the application is then able to, based on the token and the identity in the realm, go to Vault and ask for credentials for that specific tenant, which means if I compromise this application here and I try to go to Vault, I get nothing because Vault will say the application doesn't have access. If I compromise the identity of a single user, potentially I compromise one tenant, but I don't lose the data for the other tenants and I cannot make a mess through cross-tenant attacks. So this is what Keycloak is really cool for. So it allows us to really have this separation and this least privilege. In this case, we do it with realms and with tenants, but the idea is also with groups or with roles. You can really specify on a fine-grained level what you want to access. And then here you can say, well, I only give access to the tenant where the request comes from. And this is something that you cannot really do if you have machine-to-machine communication, because the machine needs to have access to all of the tenants, otherwise it doesn't work. The ActiveMQ is not that important for this discussion, but it kind of goes along a similar route, so you can also have involved secrets for that, and again, you can use the access from here, so the token to go to Vault, exchange it for a token for the machine, and then send a message. Reading a message obviously is a different story, because when you read the message, basically the event comes from the message, so you cannot say it's bound to a user. Otherwise you would have the credentials in the message itself, and that kind of defeats the purpose. So even here we needed to do a bit of machine-to-machine communication, but the main topic happens then with the user credentials, because the flow is initiated by a user is responsible for what happens, and we need to have strict auditing rules in place. Obviously this is financial data, so we need to know who created something, what did they do, and how did they do it, and we need to make sure that we only have access to the correct tenant, because otherwise it's sensitive data and we could run into troubles. So what should you do in your own projects? Well, obviously use Keycloak. I mean, everyone does it, and for a reason. It's tested, it's checked. So again, this problem of trust, what we discussed before, do I trust who wrote the compiler? Do I trust who wrote the authenticator? With Keycloak, the benefit is it's an open source project. So anyone can, and many people do as a passion and in their free time. They go through the source code, they check for bugs, they check for security vulnerabilities. The idea is that by crowdsourcing this security testing, you get more reliable or more secure software. On the other hand, it's supported by a major vendor, Red Hat, so you also get that benefit on that side, that they also take it seriously, they also test it, they also run security audits on it, so you have at least, I wouldn't say complete trust, but at least you have a higher level of trust in the software itself. Use zero trust is another important, from my perspective, topic, because it takes the good parts of this perimeter-based security, which is just checking at the entry levels, and it just makes them smaller. So basically you treat every application as its own perimeter, and then you check it every time and every place, which just on one hand forces you to automate and design things a bit better, so it's easier to check. On the other hand, it kind of forces you to to make sure that everything is secure, right? With the authentication, authorization, least privilege, and so on. I would say reconsider JWTs because it really becomes a problem that you cannot revoke them. And unless you're really handling a huge amount of requests, the benefit of not having to call the server every time is not really that great. It sounds great when you first hear it. It sounds like an amazing idea. It did to me. But once you start using it, you realize that actually this one network call to check a token that usually maybe happens depending on how you have it. If we talk machine to machine, like if we look here, or here, usually only happens at this point, and then you have machine to machine here, then this is just one call. The benefit is really negligible. And the final point, and yes, maybe one thing to think about when it comes to JWT, just this part here, I would urge you to check. If you have a JWT like this, and JWTs are usually base64 encoded, and they're usually in a weird format, and usually people go to JWT.io, put the JWT there, decode it. If we talk about trust, do you really trust a web service to actually treat your, let's say, secure data in a way that it won't leak or it won't create any problems? Especially if you take something that has a larger expiry period, why would you put it in the internet, right? You're basically inviting problems. So this is a one-liner, a bash one-liner that helps you decode in your terminal. Please use that instead of JWT.io. I use JWT.io here just because it's pretty printed. And finally, my let's say stretch goal is to always use user identities instead of machine identities, just because I think that you have this nice benefit of an audit trail. You know who started the request, you know why it was started, you can tie it back to a business case. It kind of makes a bit more sense, but as I showed previously, I've also made a lot of compromises, so it's not that you always have to do it like this. Sometimes machine-to-machine communication makes a lot of sense. And with that, I think we're exactly at 1 hour, so questions now during the break with food and drinks or on LinkedIn, please.
Any question? Yes.
You were talking, thanks for the talk, first of all, it was really great. You mentioned the zero trust and explained it very well. I was wondering, I mean, there's now some regulations, compliance things kind of going around like NIS2 and others and so on. Do they even mention things like zero trust, or they just basically say, these are the requirements and how you basically accomplish them, that's up to you?
To be honest, I'm not sure if they call it zero trust by name, although I think they do, especially in NIST. But in essence, they talk a lot about, I think I call them here, security controls or security guardrails. So basically they tell you more or less that every application you have, you need to have these controls, and then you end up with zero trust.
Yeah, especially around the topic of logging out. Wouldn't it be possible to include some pub/sub, for example, that when I call the logout on Keycloak, that Keycloak then moves in the specific tenant, as we mentioned before, in the specific realm, and then says, okay, this was logging out, and then every application would subscribe to the pub/sub. So that could be something which would help to mitigate this one problem where the token would be considered invalid because it's too small timed.
You could do it, but there are 3 problems off the top of my head about it. So one is the application needs to know about pub/sub, needs to consume from pub/sub, needs to keep track. Then also, so not just read, so pub/sub, let's use Kafka as an example. So with pub/sub, the problem would be once the message is read, it's gone, right? So that means the application would also need to store these credentials or expired invalidated tokens, at least for the lifetime of the token, to make sure that the information is not lost, which means first you need to know about pub/sub. Second, you need to store locally the information on invalidated token, or use Kafka where you play back the messages and change the offset. And third is the information is not guaranteed to come when you need it, right? There's still this delay. Still you have this eventual consistency with event-driven systems. So when we talk about tokens that are anyway short-lived, the question is how much of a delay can you tolerate? And maybe it would make sense to simply just reduce the lifetime of the token. But it is an option. It would be a kind of compromise solution. What I would be really curious about is, could tools like, for example, Istio take this away from your application and actually, as far as I know, they cannot, but if you want to do an open source contribution.
And your point around the Istio sidecar,
Yes.
was this all configurable, or did you do some additional program stuff like you mentioned with Envoy?
Outside of this proxy topic, everything comes out of the box with Istio. So Istio has first-class integration with OAuth2 or Keycloak, and you basically have a YAML file that says who is the issuer of the job. You put Keycloak there, so the address of Keycloak, and then you have a separate authorization policy, so another YAML file where you just say this is the endpoint, this is the, maybe I can, let's see if I can, I don't have internet or VPN access now. VPNs are bad, remember. So in essence, it's just a YAML file where you just have like a path and then a list of groups or a list of tokens, or if you go machine to machine, basically the service accounts of the machines that have access. And it just all comes out of the box.
Thank you.
Any other questions? Otherwise, feel free to contact Damien in a networking or with a beer or something.
With a beer.
With a beer.
Okay, then thanks a lot.
Thank you.